Hello everyone, welcome you all to another random tutorial. This is the Sineth. So today we are going to talk about how to automate your favorite web-based game Chrome Dinosaur using Python language and related modules. Right. So before moving to today's tutorial, I would like to tell you that if you are interested in learning artificial intelligence, machine learning, deep learning, image processing, computer vision, or any of the field regarding to information technology, so please feel free to subscribe into my channel and hit on the bell icon, because I am planning to do different kind of interesting works throughout upcoming contents of my YouTube channel. Okay, without much talk, let's get started with our today's application. So as I previously mentioned, our today's application is about automate Chrome Dinosaur game. So basically what does that mean is that, so basically whenever you have implemented this particular desired application, you will be able to control or play your Chrome Dinosaur game with minimal supervision, which means that you don't need to hit on your space button whenever you have been reached by an obstacle, right? What do you want to do is that simply execute the desired application and watch out about the different kind of status and behaviors of your current application, right? So you don't need to play the Chrome Dinosaur game explicitly by hitting on the space button. So everything will be done by the application. So application will able to identify obstacles and skip those reached obstacles whenever they have been reached by the dinosaur, right? So everything will be done by the application backend, and you don't need to control your Chrome Dinosaur game explicitly by giving user supervisions to your Chrome Dinosaur game, right? So that's all about the basic functionalities. So let me to show you about a real-time demonstration about our desired application, right? So what I'm going to do is I'm going to execute each and every cell of my current Jupyter notebook, which is respected to the implementations of our project, right? Here we go. You can see that this is the interface of our desired application. So this is my web browser. In web browser, in a new tab, I have opened up the Chrome Dinosaur game here, and let me to explain you about the different kind of properties of our interface. You can see that here there are two bounded regions. So this particular bounded region is for detecting obstacles in front of the dinosaur, and this particular bounded region is for detecting jump attempts done by the dinosaur, right? And there are two subsequent labels for each and every bounded region here, and there you can identify a status of jumps has been displayed, which means that this will show you about the number of jumps that you have been done at a given point of time, right? Which means it will show you about the number of jumps that have been done by the dinosaur at a given point of time, right? So so you can see that in this state, you can see that each and every both of bounding regions displayed in green bounding color, which means that those two bounded regions are empty in pixels, because there are no any single pixel present in any of the bounded region here. So which means that the bounded regions are empty right now. So whenever this particular region or this particular region filled by pixels, it will convert it into red color, right? As an example, this particular region is for obstacle detection. So whenever this region has been filled by an obstacle, the bounded region or the bounding color of our region will be red, and the value denoted by the label will be 1, right? So the 0, the value, the label value 0 stands for there's no any pixel available in the region, and the 1 stands for there are pixels available in the respective region, right? Likewise, whenever this region has been filled by obstacle pixels, then this will convert it into red color and the status will be converted into 1. Likewise, whenever the dinosaur want to give a jump attempt, so dinosaur move upward. So whenever the pixels at that time the pixels of the dinosaur is also moving upward. So whenever the pixels of the dinosaur have been passed into this region, right? So this particular region will be filled by the pixels of the dinosaur, right? Whenever this particular region has been filled by the pixels of the dinosaur, the color of this region also converted into red, and the status value of this region is also converted into 1 because the region is already filled by the pixels of the dinosaur, right? So likewise, if we want to give a jump, right, the dinosaur move into this particular cell, right, then this will identify there is a jump attempt from the dinosaur. Whenever the dinosaur has successfully done the jump, the related jump, the number of jumps is also going to be incremented. Likewise, whenever it will show you about the number of jumps that have been done by the dinosaur at a given point of time, right? So that's all about the basic functionalities of our application. So let me to start the game right now. So you can see that everything is working properly this time, right? Okay, so that's about the working example. So let's get started with the basic functionalities, right? So when we consider about the functionalities, it's about a different kind of status of our application. So that this is about a normal state, which means everything is normal in this state. This is about an obstacle state, which means that whenever this obstacle block, right, this target obstacle block filled by the pixels of obstacles, the bounding color of the region will be converted into red, and the status is also converted into 1, which means it is telling there are pixels which representing obstacles inside this particular region. Okay, so next state is about jump state. You can see that whenever the dinosaur has given a jump attempt, the pixels of the dinosaur will reach into this region. Whenever this region has been filled by the pixels of the dinosaur, it will convert it into red color, and the label also converted into 1 state. And whenever the jump has been successfully done, the number of jumps also going to be incremented, right? So those are the different kind of states you can see here. So basically, let me to explain you about the working protocol of our application, right? Working protocol of our application. The first step is it will going to capture our screen, right? First of all, it will going to capture our screen, which means it's going to get a snapshot in each and every time from our screen, right? So the according to my case, the snapshot will should be equal to this kind of manner, right? So in each and every time my web browser should position in like this kind of way, right? So I have configured everything for that kind of cases, right? So therefore what I am preferring is that I'm going to place my web browser in here, and each and every time of my application it will going to capture and getting different kind of snapshots of my current screen. Then what it does is that it is going to get the region of interest of gaming environment, gaming region from this particular screen. As an example, so you can see that this particular white space is representing the gaming environment of Chrome Dinosaur game. So what we should do is we have to crop down the region of interest of gaming environment, which means the gaming region from our snapshot or from our image of snapshot of our screen, right? So what we want to do is we have to crop down the region of interest of gaming environment from the screen. So that particular gaming environment screen is very much nearest to this kind of image, right? Then it will going to draw different kind of these kind of regions and their labels, and these like this kind of jump labels and their values, and show them using a OpenCV window, right? So how to detect and how to identify the availability of pixels in these particular regions, right? So at this point we are using the concept of contours. So using contours, so the basically contours is about a pixel of the collection of pixels in a given image. So using contours we can identify the different kind of pixel collections from an image, right? And also what we are going to do is we are each and every time we are focusing on these two regions, right? These two regions, and we are checking is there any contour available in these two regions, right? So whenever the obstacle region filled by a contour, which means that this the obstacle region has been filled by the pixels of obstacles, right? So whenever the up down status region, which means the up down region has been filled by obstacle, or up down region contain any of contours, which means that this particular region has been filled by the pixels of upward dinosaur. Likewise, we are focusing about the contour status or contour availability of these particular regions, and whenever there is availability inside them, it will consider those regions are pixel filled regions, right? Okay, so whenever a jump has been done successfully, it will going to increment the value denoted by jumps by 1. So that's about the working protocol of our application. So I have explained it in briefly. So let us see what will happen and what is going to be done in implementations right now. Okay, so let me to start implementation section. So in here I have imported different kind of modules which I am going to use for upcoming implementations, right? In here you can see, first of all you have to install OpenCV, Pyautogui, NumPy, Pynput libraries. So if you haven't already installed them, simply you have to download and install using a just pip install command. So in here I have imported OpenCV library. So OpenCV, I have imported OpenCV for doing different kind of image processing activities, and Pyautogui for getting snapshots of my current screen, right? NumPy is for doing different kind of matrix functions regarding to images, right? And Pynput is for controlling my keyboard and pressing space button and other related things, and do different kind of things regarding to my hardware keyboard of the computer. Okay, so I have executed this particular cell successfully. Until now I'm going to skip this particular cell, this one and also this one. So let me to start with application entry, which means the main function of my application, right? I have globalized jumps. So jumps is this one. So this is representing the each and every jump that have been done at a given point of time. So the value of these jumps is going to be displayed as the value of jumps label in the main the interface of our application, right? Then I have I'm going to wait for 5 seconds, and I have initialized my jumps variable as 0. Then I have pressed my space button of the keyboard and wait for 1 millisecond, and I have released space button again, right? So first of all, I'm going in here, what I have done is I have started the Chrome Dinosaur game by hitting on the keyboard's space button, right? So this keyboard is a controller for my computer's keyboard, right? So you can see here this is the keyboard and it is a controller. So this is basically a controller to operate my computer's keyboard. So in here I have pressed the button of keyboard key dot space, which means the space button, and wait for 1 millisecond, and then released pressed space button from the keyboard. So whenever I have completed this particular piece of code, the game is going to be started, right? Okay. In here I have got the screenshot of my current screen and converted it into RGB manner, and I have cropped down the region of interest of gaming region, if not the gaming area, from the current screen, right? As I previously mentioned, we are going to crop down this particular region of interest from our current screen image, which means the snapshot of current screen, right? In here I have captured, or I have cropped down the front obstacle block, right? So the front obstacle block is this particular block, right? I have cropped down the region of current front obstacle block, right? And also highest jump block. So this highest jump block is this particular region, right? I have cropped down this particular region from the region of interest, right? I have cropped down this particular region from the crop down image of my current screen. Then what I have done is, so first of all I want to tell you something, is that I have created status images Y, status image Y, status image X, status image X. So these are the values which representing the bounding coordinates of region of interest of my current screen snapshot, right? So you can see I have assigned different kind of coordinate values for them: status image Y, status image X. So this is X, these are X values, and these are Y values. According to those values, I have cropped down screen image, which means region of interest from my current screen. Then I have cropped down front obstacle block by passing obstacle bounding origin and obstacle bounding ending. That also available in here, right? And the related coordinates for highest jump block is also available as highest jump bounding origin and highest jump bounding end here. So it's up to you to customize this value according to your usage and your purpose, right? Okay. In here, what I have done is I have checked about the contours of expected area by passing front obstacle block, right? What this simply doing is that whenever I have passed front obstacle block, which means the region of interest of front obstacle block from this particular image, right? I have passed this particular region from this image to check contours of expected area function. Then I will end up with the availability of contours, which means the status of availability of contours of its expected area. So let me to explain you about this particular function right now. So here you can see that check about the availability of contours of given area threshold value on an image. So whenever we have passed an image and area threshold to this function, it will going to find the contours of the image by converting it into grayscale image, and then it will convert into an etched image. Then using find contours, it will find the different kind of contours of provided image. Then passing through each and every contour, we can find out the area of the contours. If that area, right, if any image has an area greater than to the threshold value of area, then it will return, hey, there is a contour which contains an expected area or the minimum area threshold value, right? And otherwise, if it is not available any of a contour which contains minimum area threshold value, then it will return 0. There's no any contour which contains your expected area. Likewise, it is going to check about the contours and find out a suitable contour which has the minimum which has the area greater than to the provided threshold area value. Then it will return 1, otherwise it will return 0. So that's the basic functionality of this particular function, right? Likewise, we have passed front obstacle block. So whenever this the region of front obstacle block have contain any pixel of an obstacle, this availability going to be 1. Otherwise, if this particular region is empty in pixels, this particular availability also going to be 0, right? In here I have decided in what color that I have to be represent front obstacle block, if it is green or if it is blue, not blue, if it is green or if it is red. Likewise, we are deciding in what color that front obstacle color region should be displayed. Then I have pressed space button, wait key and space button here, which means if there is an availability, which means that if there is a minimum area threshold contour available, which means this front obstacle block is front obstacle block contains a obstacle, so we have to skip that obstacle by hitting on the space key. So I have hit space key by keyboard.press function. Then I am waiting for 1 millisecond and I have released my pressed space key from the keyboard, right? So that's up to now. And what I have done next is I have again called check contours of expected area function by passing highest jump block. So whenever the highest jump block, so this particular highest jump block, this is the highest jump block, so whenever this highest jump block whenever this highest jump block has any pixel of the dinosaur, this particular function will return availability as 1, which means the pixels are available here. Otherwise it will return 0. There's no any contour, which means the region is already empty, right? So if there is what I have done here is I have decided the color that should be that the highest jump block should be displayed. So this is the decision that I have implemented to decide the color of highest jump block, right? So then I have called count jumps function and I have passed the availability of contours regarding to highest jump block. So let me to explain you about count jumps function. So this count jumps function is basically the function which is capable for increasing the number of jumps by considering the contour availability of highest jump block region, right? So you can see that we have passed contour availability here, and it will do some kind of basic stuffs. And what this basically done is it will going to increment the number of jumps that have been done at a given point of time, right? So whenever whenever we have created a new jump, or we have attempted to a new jump, then it will consider it as a jump, and the number of jumps that have been done until so far is going to be incremented by this particular function, right? So this is capable for incrementing jumps whenever they have to be incremented. Okay, so that's about counting jumps, right? So in here you can see that I have drawn up different kind of rectangles, right? This is for obstacle bounding rectangle, which means front obstacle region rectangle, and this is for highest jump bounding origin rectangle. And those two rectangles are for labels of each and every labels of both of obstacle bounding region and highest jump bounding region, highest bounding region in here, right? So these are the two labels which denoting the status values of each and every rectangles, right? And then I have printed down the different kind of text on the frame, right? In here you can see that I have format the jumps by passing jumps to this particular wildcard, right? So then I have passed the obstacle status and jump status. I have put the text of obstacle status and jump status to this particular region, right? So in here you can see the obstacle status is 0 and jump status is 1. In here you can see obstacle status is 1 and jump status is 0. Here both of these status are 0. Likewise, the obstacle status are going to be printed on the frame which we are going to be displayed, right? Then I have imshowed using CV2 imshow, and I have passed the caption of my window, and I have passed screen image which is relevant, which is equal to the cropped image from the snapshot related to the screen, right? So then I am going to wait for 1 millisecond. If my if I have entered escape key, then the function will stop, and finally it will going to destroy all the windows and terminate the execution of our desired application, right? So that's all about each and every functionalities and the implementations regarding to our today's tutorial, right? So let me to summarize everything. So what it is going to do first is, right, so in here, so what it is going to do first is in here you can see that the Chrome Dinosaur game will be started by the successful termination of this piece of code. So then in here you can see that it will going to capture the screen, our current screen, and going to find it will going to crop down the region of interest of gaming environment from the snapshot of our current screen. Then it will going to crop down front obstacle block from that captured region, right? So the front obstacle region is this particular region. Then what it is going to do is it is going to crop down the highest jump block from the cropped image. So this particular image is for highest jump block. Then those two regions are going to be cropped from the screen image. Then it is going to pass front obstacle block to check contours of expected area, which means that it is going to find is there any contour available in front obstacle block which has the minimum area threshold of 0, right? It is going to find any of the contour availability. If there is a contour, which means that we have to if there is if there is a contour, which means that there is an obstacle reaching towards the dinosaur, so the dinosaur should be able to skip that particular contour by giving a jumped attempt. So in here we have given a jumped attempt to the dinosaur, so the dinosaur will able to pass down that particular obstacle, right? In here you can see that we have checked about the contour availability of highest jump block, right? Which means that whenever we are going to check about is the dinosaur has given any jumped attempt or not. If there is a jump attempt, so we have to increment the number of jumps that have been done at this point of time. Otherwise we don't need to increment the number of jumps that have been done until now, right? So this count jumps function is responsible for incrementing the number of jumps whenever a contour available in highest jump block, right? Then I have printed down the related rectangles for higher obstacle bounding block and highest jump bounding block, and then I have put different kind of text for jumps and obstacle status and also the jump status. Then finally I have import the screen image, which means the labeled screen image as a OpenCV window. So whenever I have pressed 27 the escape key, which is corresponding to the value 27, then this whole loop will be terminated and this function will be returned as a null return function. Then finally it will going to destroy all the windows by calling OpenCV.destroy all windows function. So that's all about each and every implementations regarding to our today's tutorial. I think that you have gained a lot and you have enjoyed a lot. So finally let me to sum up everything by executing our project desired application right now, right? So you can see that this is the application that we have been end up with, right? Okay, so you can see that this application is not very much intelligent. It will not behave intelligent manner because the idea is very simple and logic is very simple, so it is working according to that particular logic. But overall, it is working very much interesting way, and as a demonstration program you should try out this particular tutorial and use for your you can also give different kind of trying attempts to improve this particular project also, right? So if you guys have really enjoyed this particular tutorial, please give me a huge thumbs up, and if you have any doubt, or if you have any if you want to do any clarification regarding to the implementations or any of the concept that have been explained throughout this tutorial, so please let me to know about them in the comment section. And if you have any suggestion or if you have any ideas regarding to the contents of my YouTube channel, please let me know them also in the comment section, and I am very happy to answer for your questions, and I am very happy to see your feedbacks whenever I have the time, right? So let's meet with another interesting tutorials as soon as possible. Until then, stay safe, keep awesome, keep learning, and thank you very much.